So yesterday we started fundamentals. Okay, so fundamentals of database systems we started, and as part of it we learned about data, what is data and what is database. Okay, so yesterday we started data. Okay, so now today we are going to learn about database. Okay, so first we have to complete these fundamentals so that you will, if you understand this clearly, so that you can work with SQL Server easily. Okay, so to make it fast, I copied the theory part here. Okay, now we have covered this database also. I think here this is okay. Yes, exactly. So that means data and the database we covered. What is data? Data is nothing but a raw fact or figure that has no meaning by itself. Okay, it is unprocessed data, unprocessed or unorganized data. Okay, and we have seen different types of data, and the main types here: structured data, unstructured data, semi-structured data. Okay, you concentrate on these 3 points: structured data, unstructured data, semi-structured data. Here, structured data in the sense data is highly organized and stored in fixed schema formats such as rows and columns. That means tabular format. Data will be stored in a fixed format. Okay, that is called a table. It contains rows and columns in relational databases. That is structured data, rows and columns. Okay, and unstructured data in the sense data that doesn't follow a predefined structure or format. Okay, that means which contains other than tabular, that means other than this structured information, that means rich information, videos, images, PDF, emails, etc. Okay, so here one more thing is semi-structured data. Okay, data that is partially organized. It doesn't follow strict table structure, but still has some tags and markers to separate elements. Okay, here I have given the examples: XML, JSON, logs, API data, etc. So this is about XML and JSON we have covered. Okay, and also NoSQL we have seen. It is a type of database that uses flexible format. Okay, and example is MongoDB. Okay, and we have seen database. Database is nothing but a collection of data. What collection of data? Organized collection of data. Database is nothing but organized collection of data. Okay, so we have seen different types of databases also. Right, here we have seen the relational databases, NoSQL databases, hierarchical databases, network databases, object-oriented, several types we have seen. So it is a collection of data. It is a digital storage system where data is organized in a structured way, so it can be easily accessed, managed, updated, and retrieved. That is about database. Okay, that is about database. Now, okay, for completing this theory part, I have copied the theory part here. The next one is database management system. We have seen data, and we also covered database. Data is nothing but raw facts, and database in the sense it is a collection of organized data, where database management system is nothing but it is a software that helps us to create, store, manage, and retrieve data from a database easily and efficiently. That means using this, see, the name itself is saying it is for managing data. Database management, managing databases. That means through this software only we can access databases. It is for managing databases. That's why it is database management system. Okay, so through this DBMS we can communicate with the databases or operate on databases. Okay, so this is a software. What software? Database management system. We can manage databases, and databases contains organized data. Data is nothing but Data is nothing but raw fact, and organized data in the sense information. Okay, that is the link between data, database, and a DBMS. Okay, now see, now here, what is the exactly what benefits we get, what we do exactly with the DBMS. Okay, now see here, we can store data, we can insert new data into the database. Okay, and also we can update existing data and delete data. We can delete data from the database, and also we can query data using SQL, structured query language. We can query the database. Okay, and we can organize the data and control access and security. So you get your user ID and password to access the database. It provides security and control access. That means you can give access privileges to the other persons to access the databases. That is nothing but control access and security. Okay, and a backup recovery in the sense here, we can create backups and recover data if something goes wrong. Okay, so sometimes if anything goes wrong with the server, we can recover the data, we can restore the data if we have backup. Okay, and also we can maintain data accuracy. That means here we use certain rules. We call them as constraints to ensure valid data and correct data, and also finally the general reports. If you see here, general reports in the sense, we can create summaries, we can create charts, and we can generate reports from the data. That is about generate reports. So with the database management system, we can do all these things. with the DBMS, database management system. Okay, now see, here we have, till now we learned database management system. Okay, now what about relational database management system? We also have a relational database management system now. What about that? Now try to understand this concept so that you will understand what exactly are DBMS, what exactly NoSQL DBMS. Okay, now here you see, yesterday we learned about structured data. This is structured data. Wait, let me take this is structured data. Okay? And this is unstructured data, semi-structured data. And see, for structured data, the data is stored in rows and columns format. This is tabular format. For unstructured data has no fixed format. The examples here are videos, emails, images, social media posts, etc. Okay, and semi-structured in the sense XML, JSON. I explained about that. Okay, now we are going to learn what is exactly relational database. Now see, what is this? See, here we also learned a database. It is a collection of data that we learned under different types of databases we have. And the next one is database management system. It is a software through which we can communicate with the database, that we also learned. Okay, next one is here, RDBMS. What does it mean? What exactly it is? RDBMS. Okay, here actually different types of databases are designed and introduced to accommodate the different types of data. Different types of databases are designed and introduced to accommodate the different types of data. We have seen main types: structured data, semi-structured data, and unstructured data, right? Here, try to understand this one. Here, suppose here you see right side here. This is, here it is a database. It contains, here the data type is structure type. You see, that means structure type in the sense we can store information in rows and columns. That means tabular format. Okay, we can store information in rows and columns. That means tabular format. And these tables are nothing but relations. Okay, so a relation in the sense what exactly? Establishing a relationship between tables. Okay, it's a logical connection between the tables. Then this database becomes relational database. Since it is accommodating structured data, this is a database. Since it is accommodating structured data, it became relational database. Since it is accommodating relational data, that means data is stored, structured data, it is stored in rows and columns, it became relational database. Okay, relational database. So in order to communicate with the relational databases, this is a relational database now. Now, in order to communicate with these relational databases, in order to operate on these relational databases, a software is designed, and that is called as relational database management system. This is relational database management system. Now, this is also DBMS. This is also database management system. What is the difference? Why we are calling it as a relational database management system? Because through this database management system, we can access the databases and what type of data it is accommodating. Here it is accommodating structured data. That means rows and columns, tabular format. Okay, and we can have relations between the tables. That's why it is a relational database. And to communicate with this relational database, a software is designed, and that software is nothing but a relational database management system. This is RDBMS, relational database management system. Okay, and through this relational database management system, in order to communicate with these relational databases, a language is designed, a powerful language is designed, and that language is called as structured query language. And using this structured query language, we can communicate with the database. What type of database it is? Relational database. So in order to communicate with the relational databases, we use structured query language, and since it is accommodating relational database, this database management system is called as relational database management system. Okay, now see the examples here: SQL Server, Oracle, MySQL, DB2, PostgreSQL. These are the different types of relational database management systems. Okay, that means if you learn one database, that means relational database management system, you can understand remaining things also. These are all relational database management systems. Okay, now see the next one. What is the next one here? See, now again, what is this? This is, you see, right side, this is a database which is accommodating unstructured data. Earlier one, structured data, but here it is accommodating unstructured data. That means no fixed format, and also it is accommodating semi-structured data. That means not in rows and columns, non-relational databases. Since it is accommodating unstructured data and semi-structured data, we call it as no SQL database. And so to manage this type of databases, a software is designed, and we call that software as a no SQL database management system. No SQL database management system. Earlier one, relational database management system. Our concern is with relational database management system only, but here no SQL database also we have. Okay, we will learn relational database management system. SQL Server is relational database management system. Now see here, this is no SQL database. Now MongoDB Cassandra are the examples for NoSQL database management system. These two are NoSQL database management systems. And to communicate with these databases, MongoDB, it's a company, it is designed its own language called Mongo query language. Using this query language, we can communicate with the database here. What type of database it is? NoSQL database. And also Cassandra, it is another company. It has designed a query language. We call it as Cassandra query language, using which we can communicate with the NoSQL database. Okay. Through which software? NoSQL DBMS, database management system. NoSQL database management system. Okay, that is about NoSQL database management system, and earlier one, relational database management system. Okay, you have to understand this concept first. What type of database management system we are learning? SQL Server is a relational database management system. Okay, now see, here we have, one second, let me erase this one also. Okay, so here we have evolution of DBMS, database management systems. Go to our topic here. See, different types of databases are designed and introduced to accommodate different types of databases. Okay, what type of database management systems we have? Let us see the evolution of database management system first, so that you will understand later what type of softwares we use. Okay, nowadays. Okay, now see the evolution of DBMS first. Okay, here in 1960s, flat file system was introduced. Okay, that means here data is stored in plain text format. Okay, or spreadsheets. That means here .txt file, comma separated values. Those days people used to work with comma separated values and text files. They used to write everything in text files and .csv files. Okay, later in 1970s, hierarchical network databases came into the market. That means here data is stored in tree format. Parent-child relationship was there. Okay, they used to maintain this relationship, parent-child relationship. Okay, so here data stored like tree. IBM's IEMS was the example for it. Okay, 1980s, relational databases came into the market. It's a big revolution. So data is stored in tabular formats. That means rows and columns. So here we use SQL, structured query language, to communicate with the databases, and it supports relationships and also transactions. Acid properties we read now in our education. Okay, we learned acid properties, right? So those things comes under this relational databases. Okay, and famous RDBMSs are, I told you, SQL Server, Oracle, MySQL, PostgreSQL. Okay, these are the softwares comes under relational databases. Again, we will see that later. Next one, in 2000, web big data NoSQL came into the market. Along with the web technologies, big data came into the market. It supports huge data. We can store huge data, and NoSQL, already explained that. Okay, it was introduced in 2000. Okay, huge data we get from websites, so social media and application, different types of applications. Okay, and also this NoSQL was introduced for speed, flexibility, and handling unstructured data. I already told you that. Okay, JSON format it supports, videos, images, etc. It supports many things, unstructured data and semi-structured data. Okay, and MongoDB, I told you, that is the example here. CouchDB, Cassandra are the examples. Okay, later in 2010, if you see cloud databases, in 2010 cloud databases came into the market, slowly all the companies, they started moving their databases to cloud platforms. It was started in 2010. Okay, so no need to install in our office premises of organization's premises. Okay, so locally we need not install any softwares. In the cloud platform itself we can maintain everything. That is about cloud databases. What are the examples? Amazon RDS, Google Cloud Spanner, Azure SQL. These are the examples for cloud databases. Just try to understand the evolution of DBMSs. So now the last one is here, 2020, another big revolution. Artificial intelligence came into the market and started using real-time data and multimodal databases. Okay, so here it supports machine learning, real-time analytics, and it handles structured data, unstructured data, and graphs data together. And also here, since it supports multimodal databases, Cosmos DB, Snowflake, and Databricks are the examples for this multimodal databases. Okay, this is up to evolution of database management system, how it is evaluated. Now our concern is, as I said, relational database management system. So here let us try to understand this RDBMS concept, okay, a little bit deeper, because it is our main concern to understand it, because our SQL server is RDBMS. Okay, now what is RDBMS? What is the relational database management system? It is a type of DBMS, database management system software. It is a software, relational database management software. It is a database management software that stores data in the form of tables, Okay, here the relational part means data in different tables is connected. That means relational, related. Through what? Keys. Through keys we can connect the tables, relation. We can create relations between the tables through keys, using keys, primary keys, foreign keys, that we will learn later. Okay, and this concept was introduced by Edgar Frank Card. Okay, he was an employee of IBM company. Okay, he was a computer scientist in those days. Okay, he used to work in IBM. Okay, he introduced as 12 rules. He created 12 rules. We call them as COTS rules. He created 12 rules, 12 famous rules. Okay, to define what? To define a RDBMS, a true RDBMS. Okay, so if any database management supports these 12 rules, that becomes a relational database management system. Okay, so here you see, next one, this is relational database management system, and these are the 12 rules we have. These are the 12 rules. Okay, now see the first rule here. Try to understand the first two rules. Okay, now the first rule is information rule. Out of 12 rules we are seeing starting 2 rules. Okay, first rule is information rule. Okay, here you see all data should be stored in tables. That means rows and columns. All data should be stored in tables. Okay, that means rows and columns. You see here we have a table, employee table we have. Okay, employee table. This is employee table. Okay, here you see these employee ID, e-name, job, we call them as columns. or fields or attributes. We call them employee ID, e-name, job. Okay, employee ID, e-name, job. We call them as columns, fields, or attributes. Okay, attributes. Now we have here rows here, you see, records here. 101 Rahul manager, 102 Ravi salesman, 103 Kumar accountant. Okay, these are the records. These are the records. We also call them as rows. This is one row. This is one row. This is one row, and this is one row. Okay, this is one row. We call them as rows or records, tuples. Whereas employee ID, vertical one, you see, this is column, this is a column, this is a column, or field attribute. Whereas these records are called as rows or tuples. Okay, now this is about a table. All data should be stored in tables, tabular format. That is about first role. Okay, now see here, what is a column? What is a column? Here, column in the sense what? A collection of values belongs to one field. Collection of values belongs to one field. This is one field. This is one field. This is one field. That means what is a column? This is a column or field. That means collection of values. These are the values. These are the values. Collection of values belongs to one field are called columns. Columns. Then what about a row? What about a row? Here you see here, row is nothing but collection of field values. This is one row. This is one row. This is another row. This is another row. That means collection of field values. Collection of field values is nothing but a row. Okay. Then what is a table? Table is nothing but a collection of rows and columns. Table is nothing but rows and columns. Rows and columns is nothing but a table. Then what is a database? Database, it is a collection of tables. Collection of tables. That means database in the sense collection of tables. Table in the sense collection of rows and columns. And also a row is collection of field values. And finally, column is nothing but collection of values belongs to one field. Okay, that is about a table. That is about a table and a database and a row, a column. Okay, now you see the second rule here, guaranteed access rule. Guaranteed access rule. This is second rule. Which rule? COTS rules. Okay, so what is this guaranteed access rule? Every table must contain primary key to identify a record uniquely. Every table must contain primary key to identify the records uniquely. Okay, primary key to identify the records uniquely. That is guaranteed access rule. Okay, now see here we have a simple table here. Employee name, job title, salary, date of joining we have. Employee name, job title, salary, and date of joining we have. Okay, for example, here we have three records. Three records we have. Okay, now what is the second rule? Every table must contain primary key to identify records uniquely. Okay, suppose a company contains 10,000 employees or 20,000 employees. Okay, that means how many records we get here? 20,000 records we get here. For example, I gave three records. Suppose a company contains 10,000 employees or 20,000 employees. Okay, if the number of employees is 20,000, then 20,000 records we get. 20,000 records we get here. Okay, now let us try to understand this clearly. First, assume there may be number of employees with the same name. See, Rakesh V, with the same name, okay, and the same job title. Assume that same job title we have, same salary, okay, and also sometimes the date of joining is also same. Assume this is date of joining is also same. Just assume this, okay. Now, how do you identify a record uniquely? How it is possible? Okay, how to identify a record uniquely, right? So here, what is this? Okay. Now, suppose if I want to update information in the table, if I want to update information in this table, first I need to identify that record uniquely. Na? How it is possible? How it is possible? How to update this record? Okay. So here same names we have, same job titles also we have, salary is also same, date of joining is also same. Okay. So in this case, it is difficult to find out, difficult to identify record uniquely. Okay, that's why if we have primary key column like employee ID, if we have, then we can easily identify a record easily, right? 101, this is 102, and this is 103, 103. Okay, that means we can easily identify the records easily using employee ID. Okay, using this employee ID we can identify. This is called primary key. This is called primary key. This is called primary key. Okay, so here one employee ID is given to one employee only. The same ID we cannot give for another employee ID, right? So 101 is given for only one employee. 102 is given for only one employee. 103 is for one employee. Okay, so with this we can identify records uniquely. And also here employee ID is the example, but don't think here we can have any other columns also if they are unique. If we maintain that if serial number is there, example in a table we have serial number, that is also a primary key. Okay, or account number we have in banking applications. In banks they use account number, account numbers. So account number is a primary key. In customers table, if we have account number, you can easily identify a record, a customer record easily, right? And also government organizations, they use Aadhaar cards, Aadhaar numbers they use. That means, see, account numbers in banking system, Aadhaar number in government organizations, and also PAN number in income tax department. Okay, and also election department, if you take voter ID, they maintain voter ID. We don't get duplicate records because these are the primary keys they use. Primary keys using which we can identify records uniquely. Okay, that is about guaranteed access rule. Every table must contain a key to identify records uniquely. Okay, that is guaranteed access rule. And these are the examples. Okay, if we have anything, a serial number in a table, and if it is unique, so you can use it as a primary key and identify the records easily, uniquely. Okay, now let us see the RDBMS features. Okay, let us try to understand one by one here. The first one is easy to access and manipulate data. Relational database management systems features we are talking about. Okay, relational database management system. First one is easy to access and manipulate data. Less redundancy. That means redundancy in the sense what? Duplication of data. More security, guarantees data quality and consistency. That means data integrity. Fifth one is supports data sharing, supports transactions. Let us see one by one. Okay, just try to understand one by one here. Here you see the first one is easy to access and manipulate data. Easy to access and manipulate data. Okay, now in RDBMS, data manipulation means working with the existing data inside the tables. That means adding, changing, removing, that means deleting data. Okay, actually in earlier days, olden days, before RDBMS was introduced, so working with the data was very hard those days. Okay, so to insert a record or to update a record or to delete a record, the developers used to write long programs. They used to write long programs. Okay, in traditional programming languages like C language, COBOL, etc. They used to write long programs. Okay, even for simple tasks also they required to write big code, and they must be expert in that programming language. But after RDBMS it is introduced, or when it is introduced in the market, when it is came into the market, everything became easy. Because instead of writing long programs, we just write short commands or queries using a language called structured query language. That means it is easy to access and manipulate data. It is one of the features of relational database management system. Okay, now see, the next one is less redundancy. What is the next one? Less redundancy. What is redundancy? Duplication of data, right? Okay, so actually in old systems that time redundancy was more. Okay, but in RDBMS it is less redundancy. Just see, here we have one example, employee table. Here you just try to understand this one. Employee ID we have, employee name, salary, department number, D name, location we have. Okay, so here we have, these are the columns we have. So here we have, assume that we have 100 records. Okay, 100 records we have. For all these 100 records, for all these 100 employees, these are the employee records now, right? So for all these employee records, you see data, department name, location, they are repeated. HR, Hyderabad, they are repeated. Okay, anyhow, they must contain they must have department number. But along with that, we are maintaining department number, location. Okay, so unnecessarily we are maintaining this department name and location, and these are repeated here. These are repeated. Department number we can maintain, but along with that we are maintaining department name, and also along with that location we are maintaining. Okay, so here we have redundancy. This is repeated data. We have redundancy. What is the problem with redundancy? Memory wastage. Here we have 100 records. Tomorrow if we have 10,000 records, 10,000 employees, that means unnecessarily we are maintaining this department information here, and it is wastage of memory. Okay, and also we have another problem here. If we want to change a department location, HR department location is changed, Hyderabad to Mumbai. It is changed from Hyderabad to Mumbai. Then in 10,000 records, if we have 10,000 records, in all the records we have to change Hyderabad to Mumbai. We have to change the location from Hyderabad to Mumbai. Okay, very difficult task, right? So here we have 100 records, we can update easily. But if we have 10,000 records, then we cannot do it. It's impossible, right? Okay, possible, but it takes a lot of time. Unless we are managing the data, we are maintaining the data, that is waste of memory. Okay, now deletion is also problem here. Because here Actually, suppose, and here, if you want to records, delete records, we are losing this information also. Let me explain that. Okay, suppose an employee is resigned. Okay, now we have 99 records, no problem. If I ask a question, what is the name of the department whose department number is 10, easily you can tell that. Okay, by seeing this, here department number is 10 and the department name is HR, you can tell that. Okay, suppose all the employees are not there, or we miss that data. That means if I ask you question, if there is no data here, if I ask you question, what is the name of the department number, 10 or 20, you cannot tell that because there is no data here. You cannot tell that. Okay, because all data is removed, all data is deleted. Okay, so deletion is also problem here. Okay, so here, in order to solve this problem, RDBMS says to maintain this data in multiple tables. Okay, that means split the tables and maintain the relationship between those tables. Now see, same information we are maintaining. One is employee table here and another table department table. Okay, same information, this data is splitted here, and this is one table, employee table, and another table, separate table we are maintaining for the department table, and these two are linked. Okay, now how it is linked? Here in department table, we have a department number, and the same department number we used here in employee table also. We used. Okay, so in that way we can link these two tables, right? So employees departments, many employees can belong to one department. It is a relation. We are maintaining a relationship between these two tables. Okay, two tables. Now actually this department number, by using this we are identifying this record. That means this is a foreign key, this is a primary key, and this department number we used in employee table, that means it becomes a foreign key in the employee table. Okay, again we will learn that concept later. What is a primary key, what is a foreign key, that we will learn later. Okay, actually we have to work on it, relations, how to maintain relationship between the tables and all, we will see that later. Okay, now finally, what is the advantage here? What we get? No redundancy. Since we are not maintaining all the department information in one table, there is no redundancy. Okay, it is reduced. Okay, and easy to update. Suppose if I want to change the location of department number here, Hyderabad to Mumbai, I can change in this department table. Okay, so one simple change, one update in department table is enough. I need not change like this here. In all the records I have to change here. Here that problem is not there. Okay, and no accidental deletion. Suppose we miss this information, that means we are losing information of department also. Here that problem is not there. Even you miss this information, you will get your department information, it is safe. Okay, now the third one is more security. The next one is more security. You see, I just opened here my SQL server software here. This is SQL server software. This is SSMS. Okay, SQL Server Management Studio. It is asking user ID and password. It is asking to log in into the SQL server. That means RDBMS provides provides more security. Okay, it provides more security. Okay. Now the next one is guarantees data quality and consistency. Data quality and consistency. Combinedly, we call it as data integrity. Data integrity, data quality and consistency. RDBMS allows only valid data. RDBMS allows only valid data. That means correct data, correct data. Here you see, we have employee table here, employee ID we have, e-name, salary we have. Okay. Okay. Here you observe this table. What's wrong here? You try to understand this one. What's wrong here? Here, duplicate ID. See, 100 is repeated. Employee ID is repeated. Okay, but it must have a unique ID na. Every employee must have unique ID. Employee ID is given to one employee. That employee ID cannot be given to another employee. Right? It is repeated. This is one problem. And missing name. Employee must have name na. Okay. This is incorrect data. And also you see salary part here. Salary is minus 2000. So, but salary must always be positive na. Right? So in order to avoid these issues, RDBMS has given a solution, and that solution is called as data integrity. Data integrity. What is this? Quality, data quality and consistency. Quality means what? Only correct or meaningful data is allowed. Correct or meaningful information is allowed in tables. Quality in the sense correct or meaningful data is allowed in the tables. Okay. Now, what about data consistency? Data consistency. Data consistency means that data is accurate and it is same across all the parts of the system. That means tables. That means tables. Here, for example, here employee table we have, and also we have project table, and also we have project table. Okay. In employee table, an employee name is here, you see A, employee name is A. We have a record in employee table. Okay. In the project table, here project ID dot dev team is the table where we have employee number. Employee number is 1, and for this employee number A, employee name is here, and the department number is also here, 10. That means this data is same in both the tables. That means data consistency. We call it as data consistency. It is same across all the tables. It is same across all the tables. Okay. It maintains same information in all the tables. That is about data consistency. Okay. Now see the fifth feature, supports data sharing. Data sharing. Okay. Here it allows multiple users and applications to access and use the same data at the same time. Multiple users can use the data, so data can be shared among the users. Developers are there, they can work on same data. Users are there, they are trying to retrieve the information, they can access the data. That means data we can share among the users. Okay. And also applications, whether it is web application or mobile application, we can share all the information with the users or the applications. That is about, it supports data sharing. Okay. RDBMS supports it. Okay. Next one, supports transactions. It supports transactions. It is another feature of RDBMS. A transaction is a group of one or more SQL operations. SQL operations, that means insert, update, delete. Okay, we have certain operations. Okay, so group of one or more SQL operations, collectively call it as transaction, that are treated as one single unit of work. One single unit of work, that is a transaction. Okay, here first we must understand, actually a transaction concept you see here, it says all operations must succeed together, because transaction is nothing but a group of SQL operations, group of one or more SQL operations, right? They are treated as a single unit of work, single unit of work. That means all operations must succeed together, because group of operations we are collectively calling it as a single unit of work, single unit of work. So when we are considering SQL operations together as a collective or unit of work, single unit of work, all operations must succeed together, otherwise it should not happen. None should happen. That means it has to fail. Even one operation is failed, it has to roll back everything. It has to roll back everything. That is called transaction. Transaction. Okay, you might have studied about properties of transaction, acid properties, atomicity, consistency, isolation, durability, and all. Okay, that we will see later when in transaction concept. I will explain that later. Okay, now what we call it as, here we treated group of application as a single unit of work. Now here you just try to understand this example. Bank transfer is there. Imagine bank transfer. We have bank transfer. We are talking about bank transfer. When we transfer the amount, first it has to deduct. We are transferring 1,000 rupees from A's account to B's account. We are trying to transfer 1,000 rupees from A's account to B's account. Okay, so it is a transaction. Why it is a transaction? Here two operations are there. First one is it has to deduct 1,000 rupees from A's account. At the same time, once it is done, it has to add that 1,000 rupees to the B's account, and collectively we are calling it as a single unit of work. That means both steps must succeed together. Both steps must succeed together. If the second step fails, the first one must roll back. That is a transaction. That is a transaction. Okay. And we also have another example, movie ticket booking system. Movie ticket booking system. Here we have four operations. It's a single unit of work. First one, it checks seat availability. When we try to book a ticket, okay, here it checks seat availability and reserve the seat. That means updating seat status. We make the payment. That means insert into payment table, confirm booking, insert into booking tables, and immediately it has to send SMS or email to the concerned person who has booked his ticket, movie ticket. Okay, this is a single unit of work. Single unit of work. If anything goes wrong with the third step, make payment, it has to roll back. It has to cancel all the steps. It has to cancel all the operations. Okay, that is about transactions. Okay, now see, the next one is RDBMS softwares. Next one is RDBMS softwares. Okay, what types of softwares we have? Let us see. Here, SQL Server is an RDBMS software which is developed by Microsoft. Microsoft developed SQL Server software. It is an RDBMS software. Oracle Corporation has developed Oracle software. It is from Oracle Corporation. Oracle is from Oracle Corporation. And MySQL, it is developed same Oracle Corporation. It is from Oracle Corporation. And DB2, it is from IBM software, IBM company. Okay. PostgreSQL is from PostgreSQL Global Development Group. It is group. Okay, so it is from PostgreSQL Global Development Group company. And RDS, it is from Amazon. All these are RDBMS softwares, relational database management softwares. Okay, what about NoSQL? I told you MongoDB and Cassandra are the different types of databases, okay, which supports unstructured data and semi-structured data. That means NoSQL databases. These are NoSQL database management systems, database management systems, NoSQL DBMSs. Okay, these are examples for NoSQL. Okay, so after relational database management system, after NoSQL database management system, we also have ORDBMSs, object relational database management systems. What is this? Object relational database management system. It is a combination of relational database management system and OOPS, object oriented programming features. Object-oriented programming features. What OOPS provides? Reusability and security. Reusability and security. Anyhow, RDBMS is providing security na? It is providing security. Okay, and rest is reusability. It has adopted reusability features from OOPS concepts. That's why it is object relational database management system. Okay, so ORDBMS, it supports reusability. Okay, now here SQL Server, Oracle, PostgreSQL supports ORDBMS features, but not completely. That means partially they support ORDBMS features. Okay, which software? SQL Server, Oracle, PostgreSQL, they support ORDBMS features. Okay, that's why we can call SQL Server as RDBMS and also partially ORDBMS software. ORDBMS. Okay, now after that we also have object oriented relational database management system. Object oriented relational database management system. Earlier one, object relational database. Here object oriented relational database management system. It is a hybrid database model. It is a hybrid database model and which combines RDBMS features and also object oriented programming features. That means objects, classes, inheritance, encapsulation. Okay, so an OORDBMS allows to store, retrieve and manage objects, not just rows and columns. They store objects inside a relational database management system that is called as object oriented relational database management system. Okay, so after this what softwares we have? Object oriented relational database management system. After this, actually the focus is shifted to shifted based on use cases. That means the way how we handle the data, for that they design different types of softwares. For unstructured and semi-structured, we have NoSQL, right? In the same way, time series, if you take time series, we use time series database management system. That is also a database management system which supports time series. For social networks, interconnected data, graph databases. Okay, so we use Cosmos DB, cloud. Okay, cloud, if you consider cloud technologies, Cosmos DB we have, Databricks we have, Snowflake we have for cloud databases. Okay, so what is Cosmos DB? It is a globally distributed NoSQL database service by Microsoft Azure, whereas Snowflake, it is a cloud-based data warehouse platform built for data analytics and business intelligence. Okay, that is Snowflake. And Databricks is about It is a unified analytics platform built on Apache Spark, ideal for big data processing and machine learning and AI, artificial intelligence. Okay, so finally, the way how we handle the data, the softwares also we have to use based on the use case. Okay, so that is about the fundamentals. Okay, next we will start SQL Server tomorrow. Okay, now let us close the session. Any doubt you have, you can ask me. Tomorrow we will start SQL Server. Okay, no doubt. Okay, so we can start. That means tomorrow is the third demo session. Okay, we can continue tomorrow, right? Okay, fine. Okay, fine. Okay, thank you. Good night.